Ever pondered over the seemingly insurmountable problem of object recognition? How do machines distinguish a circle from a square or a line from a curve? The answer to this conundrum lies in a method known as the Hough transform. This is an elegant method for direct object recognition that transforms a problem to another domain, solves it, and then brings back the solution to the original domain. It's like how we've been using time and frequency domain concepts, such as Fourier, throughout our lives. The Hough transform exploits the fact that a large analytic curve may encompass many pixels in image space, but can be characterized by only a few parameters. This feature is a significant advantage of the Hough transform. It can detect lines or curves that are very broken, even after initial edge detection. Edges need not be connected, and the complete object need not be visible for the Hough transform to work effectively. However, every coin has two sides, and the Hough transform is no exception. Despite its benefits, the implementation can be a tad awkward. You need to know what you're looking for, which may not always be the case. Furthermore, the Hough transform can only detect lines or curves that are analytically specifiable, or those that can be represented in a template-like form. The process of transforming from image space to Hough space is quite intriguing. A line in the image corresponds to a point in Hough space. Given a set of points, you find all parameters such that a certain condition is met. These parameters are then used to find the most likely parameters for the most prominent line in the image space. Improving the Hough transform algorithm involves discretizing certain values, incrementing counters, and finding local maxima. However, the process is not without its challenges. Determining the size of the cells and the number of lines can be difficult. The Hough transform can also fit circles. This involves quantizing the parameter space, iterating over every edge pixel for every radius value, and finding local maxima in the Hough space. In conclusion, the Hough transform is a robust method for object recognition, working on disconnected edges and being relatively insensitive to occlusion. It is effective for simple shapes such as lines and circles. However, the trade-off between work in image space and parameter space must be considered, and handling inaccurate edge locations can be challenging. The success rate depends directly upon the noise in the edge image. While the Hough transform can detect arbitrary shapes from edge-detected tokens, it can be slow, especially for objects in arbitrary scales and orientations. Nonetheless, the Hough transform remains an integral tool in the field of computer vision.